Hello, this is Team 16 presenting for COP 4331. My name is Brittany Staten.
I'm Omar Kalam.
I'm Rebecca Engelhart.
And I'm Alexandra Ariola.
Our application is called Acchord. Our vision for this application is to be for musicians, uh, to aid them through the creative process. So essentially, what we do is we take input from the user of certain chord progressions, and then the user receives back a Spotify playlist that has a list of songs with all those same progressions, and adds that playlist to their Spotify account. We looked and did not find any other application or website that does what we're trying to do and what we did. So there's very unique website. First thing we're going to go into, this is our landing page. Our URL is myaccord.herokuapp.com. If we go to register account, here's our register form. We enter a name. This text box is able to tell whether or not we have an email address in a standard format. It shows a red border here to let us know that, and won't accept. We have an if block that checks whether or not passwords are at least 6 characters. That's our minimum. And it also is able to check whether or not the passwords match right here. So if we go ahead and register account, it'll redirect us to our landing page. So I'm going to log out now and have Omar talk about the login process.
Right here, you just put in the email address and the password, and what happens if those meet the criteria. The email address must be a valid email, and the password is between 6 and 32 characters. Then it'll send over the email and password to our backend, and we'll compare it against our database to see if the email matches, and then if that matches, if the password matches as well. We cap it at 32 characters as a small way to protect against a few different types of attacks against the server. So if the password is greater than 32 characters, nothing gets sent to the server at all.
All right, now we are at our home page once we have logged in with our account. And also you can see in the database, if we refresh this, that user that we just created is now in here. Okay, and Rebecca's going to explain some of our navbar features.
So in our nav bar at the top here, you can see we've got a My Account tab, which you can click on. It will display all of the user account information. We've got first name, last name, email, and a bio spot that we'll talk about in a moment. You'll see we've got buttons for both update and delete. So if we click on update, we'll come back to delete. You're brought to this form here. You can change any of your information except for your email. We left it like that because the email is used to look up the user accounts to accomplish the update functionality and also the login and delete. So you've got, you can see we added a bio here so we can update. You'll see it'll bring you back to the account page, which shows all that new information. We can update or refresh our database and see that that has been changed, everything there. And also we can see that bio. If we go over to the profile page, you now have a bio over there. So I'll pass it to Omar to talk some more about our profile page.
All right. The bio takes from the user's bio, the user object's bio that's borrowed in from the database through the backend. The messages, each message sent from here goes to the backend, and then it's put into an array that's tied to the user object in the database. And with that array back on this page, what the page does is it generates HTML using recursive JSX to display each message with a delete button for each one that will specifically delete that message by more requests to the backend.
All right, and if we head back over to the home page, this is where we have our core functionality. So here we have a card that says how to use the site. The first step is to log in with Spotify. So we press this button, log in with Spotify, and using OAuth 2.0, we are redirected to Spotify's login site. So I will go ahead and log in with my Spotify account. All right, and now we see this URL has an access token, which allows us to modify the Spotify user's account. So here we'll have some chord progressions that we'll put in. So we'll start with a very popular one, 145. We'll press the submit button, and this alert will let us know what chords we typed in. So we click new playlist. And now we have a playlist of about 17 songs that has the 145 chord progression. We can do some others. 2162. Press new playlist. And we have a short playlist because it seems like there's not that many songs with that chord progression. And over here, we have our history. So if we do one more, click new playlist, we can see now we have our last two playlists that we've created and our current one that we just created. And now over to Lexi to explain how we're getting these songs, which is hook theory.
So, in order to get these songs, we created a route that does two things. First off, it authenticates to the Hook Theory API by sending a request with a Hook Theory username and password, which returns a JSON formatted response that has the key that is the token that we use as part of the request that we make to get the songs using the chord progressions that we also got from the user, which then returns an array of a JSON response with an array that has the songs, song titles, artists, and what part of the song it came from.
So after sending our chord progressions over to Hook Theory and getting this array of songs back, what happens is so we then connect to Spotify's API routes. So when we logged in with Spotify at the beginning, that this access token is what allows is Spotify giving us permission to access their database. So you can see here on Spotify, we have access. They have a whole bunch of different features that you can use their API for. We primarily use the playlists and the search. So once I get those songs back from Hook Theory, I do a loop, a linear loop that is constantly searching for each song, searches Spotify's database to get the URIs for those specific songs and those song IDs, and I take those song IDs and query their route again to create the playlist for the user. And then we, after we get that playlist ID, we embed them here into our site. Now back to Rebecca for delete functionality.
So if we go back to the account page, we've got this delete button here. If we click on that, it's going to ask you to confirm that you actually want to delete your account. And we'll say go ahead and delete. So what happens there is it sends the user information in the JSON back to the database, which will search by email and remove it. You can see here that it's been removed. So if we head back over to our site, we've got a test account in there just to show you our last couple things, which are some things we'd like to add if we had a little more time. So I'll pass it back to Brittany for that.
All right, now we're logged into our test account. So one of the biggest things that we wanted to add, number one priority, is security. Security, right now we're storing, passwords in plain text. So if we could, or if we had the time, we'd have definitely liked to make our routes, our backend routes, a lot more secure with password hashing. Another big thing is the social aspect. We weren't able to make it as social as we wanted to. You can see we have this My Friends tab. If we click that, there's nothing there. So essentially what our idea was to have a list of user IDs that so for a specific user, all their friends and their user model for MongoDB would have an array of user IDs. And based on those user IDs, whenever this component whenever this component mounted, it would display all of the IDs, all of the friends in that person's friends list. Um, Another thing is the profile. So the profile we definitely wanted to add more to. Essentially, this is supposed to be when an external user is visiting your page. This page is what we had envisioned for you to see. We also wanted to create a place to for a profile picture. Um, we wanted to be able to, so you could add songs, MP3 songs here that maybe you had soloed over a backing track or any music that you created. A big one also is showing your favorite playlist that you have generated. Um, and so anybody that goes to your page can kind of see, what you were thinking, what you have been messing with your favorite chord progressions right here. If we go back to the home page, um, yeah, that's pretty much it. Oh, another thing we wanted was so being able to create playlists based on a lot more categories, such as um, uh, key signatures, time signatures, BPMs, um, those different. Being able to create playlists for so many more different categories is one thing that we really wanted to do. So that's our presentation. Now on to questions. So, from the audience, our first question that we have is, what type of encryption would we use for password security? Bcrypt and JWT are the main two that we were looking into. Bcrypt to hash passwords, and then JWT to create authenticated routes to give us that access token. So unless you had an access token, you could not um, access any routes that led to our database. Why did we use the technologies that we did? Since we're all new to web development, the MERN stack, which stands for MongoDB, Express, React, and Node.js, it's a very popular stack. And we knew that if we ever ran into issues, there'd definitely be a lot of information out there for that. So that's why we chose the MERN stack. Next question, what other API services does Hook Theory offer? Hook Theory also has chord prediction that we thought was really cool. It gives back if you insert in a starting node for a progression, it'll give percentages back. What's the percentage of what the next chord would be? So for instance, this one has a 32% chance after the fourth position in a scale for the next chord to be the one position. And this is based on the frequency of different songs that they have in their database under different chord progressions. Okay, so that's our presentation. Thank you for watching. Goodbye.